Can everybody see that okay?
I can see it.
All right, perfect. I appreciate, the introduction, Zach. Obviously, to start this off, I really do appreciate the opportunity to speak with all of you. I recognize that there's plenty of experience and education and background in injury prevention and safety out there today. So these are always really, I'm really grateful for these opportunities. Today, I do want to touch on the art and science of technology, particularly in safety and injury prevention. And as Zach mentioned, we're certainly advancing. It feels like every day there's a new piece of tech out there that we can utilize and put into action to help improve our outcomes. So we'll dive into that a little bit. Real quick background about myself. I am the regional sales executive at Fit for Work. Prior to working at Fit for Work, I was in school. I got a bachelor's degree in kinesiology, so the study of human movement. I went to Sacred Heart University, where I achieved my bachelor's in business administration, my master's in business administration. I do have over 10 years of experience as a certified athletic trainer. So in that role, I've worked in a variety of settings. Most people familiar with the athletics, working with football teams and baseball teams and things like that. But I did gain experience in the industrial setting. I worked at a manufacturing facility for several years with Fit for Work. As an injury prevention specialist, boots on the ground. So, that's where I got into this. And then I switched over to the business development to try and spread the word of injury prevention opportunities that are out there. When we talk about Fit for Work, I'm not sure if all of you are familiar with the company, but Fit for Work is an injury prevention firm. They've been in business for 25 years. And what we focus on is early intervention, ergonomics, safety compliance, and employee testing, all designed around, preventing employees from becoming patients, right? We don't want them to end up in your traditional healthcare system, lost time, lots of money going into that, rehab, surgeries, God forbid, things like that. So all of our services are designed to prevent that from happening. And we've had the privilege and opportunity to work with over 300 companies across North America. I think it's up to 1,500 locations at this point. So Fit for Work employs a lot of people like me, so those medical professionals, whether they're athletic trainers, physical therapists, and occupational therapists. We also employ certified professional ergonomists and certified safety professionals. So we are tackling it from a well-rounded standpoint, right? Not just looking at one thing or the other. And through all of that experience, we've had the opportunity to test out these different techs that we're going to talk about here today. So when we bring up some case studies and things like that, it was our opportunity to test things out and see how useful they were. So we look at the agenda, right? I'm going to touch on work-related musculoskeletal disorders. From a statistical standpoint, these are important to focus on. We'll go over those numbers. And then obviously, with modern tech, right? There are, as I mentioned, no shortage of opportunities out there. When we look at this from a standpoint of, well, I have a lot of choices to make. Are these useful, right? Is the data that this technology giving me actionable? Can I put it into use in my day-to-day operations, right? So we're going to tackle some of the most popular topics. So software as a service, wearable technology, predictive analytics, and then we're going to tie it all together, right? How are we able to use these with our knowledge and our background to make sure we're getting the best possible outcomes? Okay, so next one. All right, so musculoskeletal disorders by the numbers, right? When we look at this, certainly some concerning figures, right? According to National Safety Council, in 2019, 31% of workplace injuries that resulted in lost time were musculoskeletal injuries, right? And we take that a step further and we look at Bureau of Labor statistics, and we see on average, 266,000 cases resulted in an average of 13 days away from work. Right. So these are maybe chronic overuse type of injuries, maybe, that one-time acute force-related lift that led to, a musculoskeletal disorder. But either way, what we see here is that lost time is certainly a result from a majority of these musculoskeletal injuries. So it's beneficial to all of us if we have that opportunity to prevent them from happening. Now, Aon Laser Analytics took a look at all industries across the board and identified that in each and every one of them, musculoskeletal injuries were the leading cause of injuries across the board, right? Food and agribusiness were number one with that 59%, but certainly right behind that, manufacturing, 48, healthcare, 45, and even construction, at 35%, right? And the last one that I want to throw at you, because especially these days, right, good work is hard to find, talented employees are hard to keep. World Health Organization identified that musculoskeletal disorder is ranked as the second highest disorder, leading to a shortening of productive years. So when you get those talented employees, the ones that know your processes in and out, that can train and create proteges and predecessors, you want to hang on to them, right? So if you're having this epidemic where these musculoskeletal disorders are shortening their productive years, you get less time with those employees. So focusing on injury prevention and reducing those musculoskeletal disorders really helps things like, retention, hiring quality candidates, reduce turnover, right? If the processes that you're implementing are easier for them to do, they're willing to go to work and work longer for you, right? So there's a lot of benefits to preventing these. So let's take a look at our options, right? We have data coming at us from every direction, right? Safety professionals have no shortage of numbers they need to review, right? Maybe you have internal metrics, lagging indicators, leading indicators, TRIR, OSHA recordables, different things like that, right? So all of these numbers are coming across your table. Do we want to add to it, right? So we have things like ergonomic risk assessment tools. We have software as a service, wearable technology, artificial intelligence, right? All of these things are going to give you data points, right? Is the data actionable? How do we utilize it to make sure that we can go out onto the floor, out to the construction site, whatever the situation may be, and actually make meaningful change? So I want to start off with ergonomic risk assessment tools. Many safety professionals are familiar with these, right? These are sort of the gold standard for ergonomic risk assessment. These are your RULA, your REBA, your revised NIOSH lifting equation, Snook and Ciriello tables. You have the Ohio State push-pull. And these are very good. And a lot of ergonomic experts utilize these tools to assess, a job process or, provide workstation redesign, help with line development. They're very helpful. They're offered in a lot of different formats, right? If you're old school, you like taking notes on pen and paper, these are available. You can print them out online and start doing them right there. But they're also available to us in a digital format, right? We can download applications. We can go online and find them there. So when we look at pros and cons of these, obviously, being the golden standard, a lot of these are utilized in the advanced tech that we'll talk about in a few slides down the road. So combining these tools is very useful in assessing the risk of a job, right? But that's also kind of the con associated with the ergonomic risk assessment tools. If you're not properly trained on when to use them or how to use them effectively, you might get skewed data that isn't necessarily effective, right? So each tool is limited for what it was designed for. So when we look at something like the RULA and the REBA, this is really designed to look at a snapshot in time, right? It's not meant to assess an entire job process over, a 5 to 10 minute period. It's looking at a postural assessment in one specific snapshot. So you can do these over and over and over again for one job process, but it's very time consuming. And you also have to understand the limitations, right? It may not look at force or it may not look at vibration. And certainly you can circle it, but it's a limited capacity to do so. So oftentimes when we look at these tools, you have to know when to combine them to provide a full spectrum, observation or ergonomic risk assessment. So that is a limitation of it, right? Being trained on the proper use and when to use them. So one of the ways that we can start making this easier for everybody, not just ergonomic experts, is this technology that helps to combine these and make things easier for us, right? So we look at software as a service, right? And there's plenty of opportunities to dive into software as a service, and there's tons of options when we look at software as a service. Almost all of them are cloud-based, right? So your data is stored in the cloud. It's easily accessible from anywhere. And when we look at the different kinds, I'm going to highlight four major sections of it, right? From an ergonomic standpoint, you have 3D modeling, right, where you can create, a sample world where, hey, I want to try and change this up and see how that would affect the worker's ability to perform the job. Very helpful, very useful, especially if you're going to commit to a large engineering control, right? Before I invest $500,000 into this entire line redesign, we can create a digital world in these 3D models. We also have e-learning. E-learning is huge, especially, in the days of COVID, right? You can hop onto this software as a service. Safety professionals have a ton of things that they need to get done, right? So training probably makes up a good majority of things you have to do. So being able to track it in real time, being able to assign it to different people, it does make things a lot easier to ensure that you're remaining compliant. Data tracking is huge as well, right? Long gone are the days of keeping a file cabinet. This allows us to look for patterns, identify issues, that we may not have spotted unless we spent hours in front of the paperwork observing the different results over time. So the data tracking software is very helpful. Now, ergonomic risk assessment tools are the ones that I want to focus on, right? These are the ones that pull together that information from those old tools, those not old tools, but the rule of the REBA, the paper format, and they've created their own type of tool, right? Maybe they can create their own assessment by combining the different metrics that those tools gave you. So they look at these, and I'm going to assess the pros and cons here, right? So when we talk about pros of software as a service, particularly ergonomic risk assessments, certainly it's scalable, right? If any of you work for a multi-location, multinational company, it's always beneficial to speak the same ergonomic language, right? If you have one site that's using one tool and another site that's using another, and you both are assessing the same position but at different locations, you come together at your monthly or quarterly meetings and you say, oh yeah, I did an assessment and it said that job position was a 10. And then this person's like, well, mine said it was a 67.8, right? You're not speaking the same language. It makes coming up with recommendations and controls a lot more difficult. So software as a service makes it a lot more manageable. Everybody starts using the same scale. They start speaking the same language. It's also digital, right? So it saves you time on calculation. You're not sitting there pen and paper, adding it up. It's giving you time, giving you calculations in real time. The other great thing, and when we try to encourage more and more people to get involved in the ergonomic practices, develop their ergonomic eyes, is the visual deliverables, right? It's not just this boring stat sheet that's like, okay, well, I'm looking at numbers and numbers and numbers, but they're very helpful visual deliverables, right? They're highlighting body parts. Some of those motion capture technologies, you can just point your phone at it and it's observing, postures and movements. It's painting a red line over certain things or circling them. So this helps to get more people involved and helps them understand ergonomic risks, right? And it also provides objectivity. This is big because, as an injury prevention specialist, when I was out on the floor, I'm observing, multiple jobs and I'm saying, there's definitely a risk involved there. But it's just me and it's my expertise saying that when you use these tools and you use software, it puts hard numbers to those observations. So I know when I hopped on, people were talking about where's the ROI, how do we prove that investing in something is worth it? Well, this is going to be able to give you hard numbers to add to that report. You can do a cost benefit analysis and say, hey, there's 57 risky situations that happen in this position, and we can show you that very objectively, right? So it does give you those hard numbers. Now we look at cons. One of the biggest things is it doesn't tell you who to evaluate, right? You have to have that working knowledge of what are the risky positions already, right? And some of you probably review the injury data and you have a good understanding of that, right? But you still need to pick which individuals you're going to evaluate, right? Certainly it's probably impossible to evaluate every single employee at your locations, right? So picking and choosing is up to you. It's not something that the software is going to be able to tell you. It does take training, right? Especially when we look at things like that 3D modeling. A lot of that is CAD based and a lot more engineering focused. So those are expensive. The training is much more intensive, right? Some trainings could be a few hours and some could be multiple days. And so you have to assess that as well as the cost, right? Is this cost effective? Some of them come with subscription fees. Some of them hold on to your data and they say, oh, well, if you want to have access to it, it's just leased. You have to pay extra for that, right? So keeping track of all of those things is important. What it also doesn't do is it doesn't identify anthropometric differences, right? And when we talk about anthropometric data, what I mean by that is, I'm sure some of you are familiar with that Leonardo da Vinci drawing, right, of the human body. And it's understanding that everybody's built a little differently, right? My arm length is not your arm length. My height, weight, body type is different. Everybody's is different. So the software does not take that into effect, right? It doesn't account for that, especially when we're looking at how and why a person is at risk, right? It might say, yeah, there's a risk involved here, but it's not going to tell us why. It's not going to tell us how to resolve it either. So let's look at a case study. All right, let's do an example here. This is at a construction site. There's actually 2 employees working here. It's a multi-step process, right? They shovel the aggregate down, and another individual is raking it and leveling it out. So we look at two of the employees that are working at this particular job. They're both doing each job, but they rotate, right? They do it for a little bit and then they switch positions. The two employees that we look at, employee one is 5'10", 170 pounds. Employee two is 6'3", 235. So these are pretty different individuals, I'd say, right? I mean, I think that's a fair thing to say. So we start doing some observations, right? And we start off by evaluating the taller employee, right? Employee two. And we see this. We notice that as he's shoveling the aggregate, he's bent over, pretty poor posture there. His feet are very close together. He's doing a lot of like chicken winging with the elbow. He's twisting his torso. So there's certainly a lot of ergonomic risk, especially when he's shoveling, right? We notice that the short shovel might not work for the guy who's 6'3". Maybe we need to get him a longer shovel. But now we go on and they switch positions and we watch the 6'3" individual level out the aggregate. And he's tall enough to reach across the patch that they're repairing, right? So he's reaching out with one arm and the rake, and he's pulling it across, right? So he's leaning, he's reaching, he's lifting that heavy object out away from him. So we start plugging this data into our software, and this is what we come up with, right? It's highlighting, this is that visual deliverable I talked about. A lot of them benefit this. So you see, some shoulder risk, lower back, neck, it's elbow, hand. And this is a great printout, right? It's showing, okay, there's a lot of risks we need to fix, right? But let's go back to this scenario and look at employee one. He's 5'10", 170 pounds. We notice that, yeah, he doesn't have to bend quite as much to utilize that short shovel, right? So he's got a pretty wide base. He's in a good linebacker position. He's not bending at his waist the same as the 6'3" individual, and he's shoveling, and it looks pretty good, right? When they switch positions, he can't reach across that patch. Right. So what he's doing is he's leveling out one side, walks around, levels it out, walks around, levels it out. So if we chose to only assess the individual that's 5'10", we would be left thinking, well, there's no hazards for this job, right? We'd plug it into that software and it would show, 1, maybe 0, 0, 1. We'd be like, all right, we're good here. We can move on, right? So the issue with software as a service is it's limited. It doesn't eliminate the need for a complex human interaction. Right, you need to go out there and understand, hey, I need to take anthropometric data into consideration. Why is this employee who's 6'3" at a much greater risk than the employee who's 5'10"? Well, we know he didn't have the right tool for the job. We know he's taking a shortcut. He thinks it's quicker to just reach across. That's not the data that's going to come out of the software, right? So realistically, we can use the data from the software, but we have to be mindful of choosing who we're going to take those assessments on and implementing it in a way that we're not just creating a cookie cutter solution, right? We understand that, hey, the short shovel worked fine for the one employee, but it's not going to work for everybody. So we have to still use our knowledge to go out there and pick and choose appropriately and implement appropriate abatements for everybody that's doing the job. So I do want to move on to wearable technology. Very common types of wearable technologies. There's some that are straightforward, right? There's ones that you can clip on you. They create a geosphere, shuts down equipment and forklifts when an employee is nearby. There's GPS locators, there's temperature monitors, oxygen sensors. I'm not going to go into that, right? Those are pretty cut and dry. I think that they're phenomenal in terms of helping to prevent, safety risks, fatalities, certainly. So I think they're straightforward. They don't need a lot of explanation. I also don't want to dive too deeply into exoskeletons. Now I'm going to, give a brief statement on it and explain why, but I think predominantly I want to focus on the wearable sensors that are looking for those at-risk movements and things like that. Now, in terms of exoskeletons, we think that there's at Fit for Work, we think there's certainly a bright future for them, right? But because of their expense, because of some of the cons associated with them, we don't recommend using them just quite yet. And so some of the biggest issues about those exoskeletons are that, yes, it might reduce some of the stresses on your shoulder, right? You clip on an upper body exo, you start doing motions, and it's reducing some of that stress on your shoulder. But some studies have shown that the transfer of forces have actually moved to your lower back, right? There's increased shear forces, there was increased compression forces on the spine. So there's lots of issues associated with it. Yes, you're eliminating one problem, but as far as we know right now, a lot of these exoskeletons are not designed to the point where it's not transferring that load to a different part of the body. We also have other concerns with exoskeletons, right? The battery life. How long do they last? Are you charging them in between users? Does that mean some people get to use them, some don't? Hygiene, right? Hygiene's a big one, especially now in the COVID world. Where are you cleaning all of these in between? Who's responsible for doing that? Are we able to utilize these with multiple people, or does each person have to have their own, right? So proper fit becomes a problem. Are they custom fit to everybody? And that gets expensive. The other thing we see is increased body temperature, right? Increased footprint. So now it's not just your body taking up space, but it's your body plus this device. So can people safely work around them? So there's a lot of things to look into before investing in the exoskeleton. Again, we certainly think that it has a bright future, but it's just not quite where it needs to be just yet. But when we do look at wearable sensors, these are little clip-on things. You can attach them to multiple body parts. So let's dive into that. What data is it looking for, and what is it giving us, right? So it's looking at-risk movements. You're wearing these things. Are you doing something that's going to put you in harm's way? It's looking at frequency and repetition. How many times do you do that at-risk movement? Are you doing it safely? Even if you're doing it safely, how many times do you do it a day? And then the good ones are going to look at muscle activity, right? And this is how much force and how much exertion is being executed by a certain muscle group. So we look at pros and cons of wearable tech. Pros, it identifies a possible at-risk behavior. And I want to highlight the word possible, and we'll address that in a little bit. But it certainly can be beneficial to say, hey, I didn't realize that this particular employee had to do so many, upper body twists, right? So it can identify that, right? It can tell us that. And it compiles that data to create and identify patterns, right? You don't have to be out there and watching for hours at a time. The employee's wearing this wearable, and it's giving you data that you can look and see that pattern, right? So with that, you can use it to help to identify top ergonomic priorities, right? It's giving you this pattern data. You're like, well, there's a lot of risks coming from this particular job. That's our top ergonomic priority. We need to come up with a solution for that area. But it could also help to reduce observation time, right? We talked about software as a service. You need to pick and choose which employees you're observing. You need to spend time doing that, coming up with a pre and post, assessment. How did your ergonomic control affect it? So it's a lot of time going into that, and this can help eliminate some of that because this sensor is detecting that movement. Now we talk about cons. You don't know who to put this on, right? Are you going to put it on everybody? There is an expense with these sensors. It's certainly not cheap to invest in a lot of them if you're going to put it on every individual. So again, that falls on your shoulders. Who do I select? Which job positions are going to wear them? Which body parts am I going to attach them to observe? So there is some, decision making to happen beforehand. Now this next bullet point, no universal definition of an at-risk movement or repetition. This is why I said it can identify a possible at-risk behavior. And that's because we can't say definitively that this motion is a risky motion, or that this motion is, or that this repetition is one too many repetitions, right? There's no universal definition of that. And that's because, some employees might be able to do 10,000 repetitions without any issue. Another employee might do 10 and get hurt, right? And when we talk about at-risk movements, let's break it down in terms of degrees, right? If we're doing a 30-degree bend at our waist, right, the sensor doesn't go off. But then we do a 31-degree bend and the sensor goes off. Does that 1 degree make it an at-risk movement? We can't objectively say that that's the case. And then this is why I also said it was very important that they detect muscle activity, because if I do a 31-degree bend with no weight in my hand, but then I do a 30-degree bend with a 75-pound weight in my hand, is the 31 risky and the 30 is not, right? So if the sensor isn't monitoring the muscle activity, you're really going to miss key data points, right? It also leaves out things like contact stress. It doesn't take into account, the vibration and different risks, ergo risks like that, right? So there are some holes missing in the wearable technology. Wearables assume that every injury is associated to physical factors, and that's not always the case. There's also some psychological effects, right? When we talk about the psychology of wearing this, is an employee going to feel like big brother's watching them all the time? Hey, this thing beeps 50 times. Am I going to get reprimanded? I don't want to get in trouble for wearing this. So you have compliance related issues, right? The other thing too that we investigate a lot at Fit for Work is pain science, right? Understanding that people's discomfort isn't just shaped around tissue damage, right? Sometimes stress, anxiety, previous injury, all of these things add to your pain. So someone hearing that, oh man, 50 times a day, this beep went off. maybe I should be feeling some discomfort. They start getting anxious about it. Maybe they start developing that discomfort. So we have to be careful with those psychological effects. And then on the other side, if the employee is hearing this 50, 60 times, a week, do they continue to hear that long term, or do they start to tune it out? Right? It's one of those things we have to keep a close eye on. It's a great tool. It's meant to observe, let these people know, provide biofeedback, giving them some recognition of, okay, I need to correct that movement. I need to correct that posture. But over long periods of time, we have to monitor to make sure they haven't become numb or deaf to that particular vibration or sound. And then a lot like software as a service, it's not going to identify why a person is at risk or how to resolve it, right? It might tell you, yeah, the shoulder has done a lot of repetitions or it's been out of position in an awkward posture, but why? It's not going to give us that information. So let's look at a case study for this, right? This is at a grocery distribution warehouse. The order selectors were given wearable sensors to monitor lower back discomfort, right? Or lower back awkward postures and at-risk movements. So what kept happening was two employees were coming up as doing improper motion, right? All of these employees received the same training. We want to promote lunges. And so we went out there, started doing some observations, and we noticed that for this particular lift, right, that heavy 40-pound case of water is in the back of the pallet. It's complex, right? It's not right there in front of you. You have to step in, you have to lunge, you have to pivot appropriately. So two of these employees were bending at the waist, right? They weren't doing that complex lift. So we talked to the employees and we wanted to find out, well, we've trained you on this. Why aren't you doing the proper technique? So we look at employee A. He says, I just had a newborn baby. I'm really not sleeping all that well, so I'm pretty tired at work, which means that my picking speeds come down, right? I'm nervous that I'm not going to be able to keep up with these other selectors. They're going to let me go, and that just can't happen, right? I have this newborn I have to take care of. And so he thinks that bending is quicker than that complex lift, right? So that's employee A. We understand why he's doing it, right? Now let's look at employee B. He's like, I have a previous history of knee injury. I had surgery, and now I'm afraid that if I do that lunge, it's going to re-injure my knee, right? So very different reasons why they're doing the same awkward movement, right? We didn't get that information from the wearable. We had to go and find out. The other thing here is, do you think we handle both of these situations the same? We obviously can't, right? We can't sit there and say solution for employee A is going to be the same solution for employee B, right? So employee A, what they're going to need to do, obviously sleep, we get it. You have a newborn baby, you're not going to get the same kind of sleep. It's just not going to happen. But what we can coach you on is how to get better quality sleep, right? Make sure that you're not drinking before bed. Make sure that you're limiting your screen time. You're sleeping in a cool, dark room. We're also going to partner you up with another selector who's doing the best practice and meeting those picking speeds. And maybe we conduct a time study, right, to demonstrate that lift is actually not faster. So why are you putting yourself in extra harm's way when you don't have to pick up your picking speed? Whereas employee B, he's going to need some pain science education, right? That knee injury is probably not hurt anymore. You just have some fear avoidance. You're afraid of that posture. And what's actually going to happen is if you don't do that movement, and one thing we do know is motion is lotion. So if you don't do that movement, you're going to start losing strength. You're going to start losing range of motion in that knee. So it's actually going to have the opposite effect. So we might give this employee some strengthening exercises. Here's how you can strengthen up that knee so you're good, you're strong, you can go ahead and do that lunge and not put yourself at risk for a lower back injury. So you'll see a theme here. Wearable sensors are great, but they don't eliminate the need for a complex human interaction. You see, you had to determine why and you had to determine how, because it's not giving you that information. And it's a complex human interaction that tells us those intricate details that we need to come up with those best practices and individualized solutions. So let's look at predictive analytics. Predictive analytics is designed to identify employees who are at risk for developing a discomfort. So what it does here is it collects data that's been put into the system, identifies patterns that have led to discomforts in the past, recognizes those same patterns popping up in the present, so we have a chance to interact and intervene with an employee before it does develop into an injury or a discomfort. So what type of data does the predictive analytics need? Well, it's going to look at the type of interaction. So what is that employee doing? What's their job? Have you worked with them, to coach them through it? Have you talked to them about previous injuries? How frequently are they working in that position, right? How frequently are they doing that particular process? Then we're going to look at the quality of movement, right? Is it good quality? Is it bad quality? This is all self-reported, right? It's not collecting this data for you. You're putting this in. You did observations. You're putting that into the system. It's also looking at the psychology of the worker, right? If we go back to that previous case study, obviously employee A was stressed out. He's not getting enough sleep. He's worried about losing his job. It's going to look for those buzzwords in the report, pull it out, and recognize that that's part of a pattern that might lead to an injury down the road. And certainly the history. How long have they been working for your company? Do they have any previous injuries, right? And it's gathering all this data so that we can go out and identify who we need to talk to prevent an injury from happening. So let's look at pros and cons of artificial intelligence. This does identify your at-risk individuals, right? It's telling you who you need to focus on. Software as a service, wearable technology, you have to identify who's at risk to observe or to give that wearable. So that's on you, whereas AI allows you to know which employees are most at risk. It's collecting that data and finding that pattern so that you can target those individuals. And it's, that's the big part of this is it's compiling data and identifying the pattern. It can also, much like the wearables, help you identify top ergonomic priorities. You see names coming up, all doing the same process, all working in the same area. You are likely knowing that that's an area you need to pay attention to. The other great thing or, terrifying thing about artificial intelligence is it improves accuracy over time. The more data you give it, the smarter it gets. The more patterns it can identify, the more accurate it gets. And so this is fantastic, but at the same time, it requires user input, right? And that's that con right there. It can't create data from nothing, right? If you don't put data into it, it's not going to work, right? So it does require upfront implementation where you're giving it and feeding it information, right? It doesn't identify your at-risk behavior. So, oh, you okay? Okay, sorry. So it does not identify your at-risk behavior. It'll tell you who to interact with, but it won't tell you why. It won't necessarily identify what body parts, at risk. So you're going to have to determine that. And it doesn't identify why or how a person is going to get better, right? If you talk to an individual who's at risk, well, why are they at risk? And how are they going to get better? How do we resolve it? So again, the theme is here. Predictive analytics doesn't eliminate the need for a complex human interaction. So the art of it all, we talked about the science, all of this data recognition and pattern identification. That's part of the amazing science behind all of these things. But the art is knowing how to apply that and talk to people, right? So technology can find patterns that humans can't, but humans can provide that personalized attention that technology can't, right? Maybe this person's dealing with, an improper ergo technique because of an injury. Maybe they don't like their manager, and so they're like just doing whatever the heck they want to do just to make them mad, right? Maybe the employee's morale is down. He has bad numbers the last quarter. Maybe he thinks that, he had that knee injury and he's never going to get better, right? So those are the personalized attention things that we need to focus on. So we break it down into a chart. We see there's a lot of emptiness here, right? Certainly these tools are beneficial. We can recognize what the risk is when we use software as a service. We can do some ergonomic risk assessments and it'll tell us, yeah, the shoulder or the back or this process. Wearables they're going to identify those patterns and tell you what. AI might tell you who, but the why, the how, sometimes identifying who, that's going to be on us, right? That's on our safety professionals, on our ergonomic experts or injury prevention specialists, right? We have to apply our knowledge in conjunction with these to make sure we're doing the best we possibly can. So let's tie it all together. What does that look like? Oh, this is a case study from when I was on site at a manufacturing plant. So I had been there for about 2 years. I was doing observations. I worked with this particular employee over the course of time. Maybe he had some elbow discomforts, coached him on some manual material handling. And I was documenting all of that into our software, right? So we're utilizing software as a service. What I ended up doing, logging in one morning, was I popped in, his name popped up. Now, in my mind, he had just been promoted to a team leader. His body wasn't getting stressed out as much as he was when he was a production employee. So I was thinking, there's other areas I could focus on. But when his name popped up, for whatever reason, maybe it was I hadn't seen him in a while, but the AI had identified a pattern that I needed to go and speak with this particular employee. So I go out, I follow him out to where I know he's team leader and look at his line. And this is part of what I observe, right? I see him out there and he's pulling an empty cart. So this is the production line. He's pulling an empty cart from the edge of the production line and shuffling it back into the empty cart line. Now I'm confused by this, right? Normally what happens is you load the cart up with product and it gets taken away by a forklift. So I'm thinking to myself, well, why are you adding it back to the empty cart? It's got no product on it, right? So I'm thinking, well, there's extra repetitions. Why is he doing that? He doesn't need to be. I'm looking at his behaviors, right? And he's fully extended. He's pulling this cart, fully exposing his pectoral muscle, his shoulder. So certainly a chest injury, a shoulder injury might occur from this. And also where he's walking, he's getting really close to where those forklifts drive, right? If he's pulling this cart back into this alley over here, the forklifts are driving right over here and you're getting a little bit close. So there's some safety risks as well. So I certainly want to find out, why are you doing this? And then I want to work on developing some controls. Behaviorally, I can coach you through that, but let's, dive into it a little bit deeper and find out what's the cause, right? So this is to give you another picture of the layout, right? This is where the empty carts are. The forklift comes over, delivers the carts. The employees at the loading area pull the cart from here to here, load it up, push it over here, gets taken away by a forklift. But this is the blue path is the path of that team leader, right? So clearly not ideal, not an ideal situation. So I approach the employee and I ask him what's going on. Why are you taking an empty cart back to the line? And he tells me, he's like, Kyle, there's a buffer on the bottom of these carts that protect the product from being damaged. And this particular cart, that buffer was worn out. So unless I absolutely need to use it, I don't want to use it right now. So I shuffled it back into the end of the line. So root cause right there is now I learned that it's a cart maintenance issue. This cart never should have gotten to that loading area before being inspected, right? So I know that, from an administration standpoint, let's come up with a control where we have a cart maintenance routine. Let's make sure before this forklift driver delivers it there, we can investigate that. Now, the other thing I want to do is obviously coach him on how to properly move that cart. He's a team leader, right? So in essence, he's a role model. So even if, the carts are good, these employees still have to move it from here to here and from here to here, right? So I want to make sure they all know how to move that cart appropriately. And if he's doing it improperly, what are the chances that his employees are, or that he's going to correct it, right? So I provided some small group training, some behavioral coaching. Let's do some team pushes and pulls, reduce that stress on one another so we can do that. And then I actually left the facility, but what they were working on was an engineering control that would deliver the carts without that manual material handling. So making it even easier on the employees through an engineering control. So when we talk about these different options, right, what's available to us, these are great tools. I don't want you to shun these away. I want you to utilize them, but we have to keep them in our back pocket and make sure that we're getting out and talking to those employees, right? The key element here is using the data that those ergonomic tools are giving us, whether that's modern technology, whether that's the paper format of the ergonomic risk assessments, but we have to have those complex interactions to learn about our employees. And so thank you. I appreciate your time, some references, but I do want to turn it over to you for questions.
Hey, Kyle, this is Larry Peterson. It's not a question. It's just you did a fantastic job of going through that material. It's one of the better presentations I've seen in a while.
Thank you very much. I'm glad you enjoyed it.
Hey, Kyle, this is Hank Austin. Can you hear me?
I can, yeah.
Hey, what is your favorite overall software package to use for the industrial field there?
Yeah, so there's certainly a lot of options. I mean, I'd be biased. I think, Fit4Works proprietary portal is very beneficial, but obviously, as I mentioned, that requires years of accumulating that data. There's another one that I've seen, from an ergonomic standpoint that's been pretty good. Gotten some good feedback on, and that's Ergo Factor. is pretty good from an ergonomic standpoint. But do your due diligence. There's lots of offerings, different things you might be looking to accomplish at your work site. But those are the two that I've had some pretty good experiences with. Hey, Brian, could you elaborate on that question? Brian Weatherly?
Yeah, Kyle, it was really good. Loved the presentation. I really enjoyed, especially on the wearable tech part. There's so much going on with that right now.
Mm-hmm.
Society had another presentation about the Internet of Things, right, for those devices. Are there any big devices and setups that you guys are looking at that kind of make you guys go, this looks really kind of like it might be good? Just getting your opinion, fun stuff going on.
So I can definitely look into that. I'm not 100%, well versed in the IoT now that I know what IoT stands for. I get the concept. Those geospheres that I was talking about. Where machines shut off. But let me talk to my team and I can get back to you. Why don't you put your email address in the chat and I'll send you an email.
Yeah, you bet. And Michael and team, those guys in Forest, they have my stuff too, just in case.
Perfect. Anybody else? All right. Zach, I wanted to just take some time to thank you again for letting me to present. Obviously it's always humbling to speak with everybody. I know you have plenty of experience out there. So again, really do appreciate the opportunity.
No, thank you, Kyle. I appreciate you taking the time and educating us all on this. I think it's a much needed subject, one that I think that we're going to continue to battle for more years to come. So thank you from all of us as well.
Okay. No
if nobody else has any questions for him, I'm going to put on that construction summit that's coming up. Let's see. That Victor was talking about that we should see all that's going to be. Can everybody see my screen? Yay, nay?
Yes.
We can see it.
Yes, sir.
Okay, awesome. So here's the San Antonio Construction Safety Summit. It's their 5th conference, October 26, 2021. I put in the link up above to RSVP. If you want to be a sponsor, I believe they're still taking sponsorships and everything. Our chapter did sponsor this event. So there will be about 5 or more or so officers and members already that are going to be there. So we look forward to seeing y'all on the 26th. If nobody else has anything, I want to thank everybody for attending and joining. If you would please fill out that survey, give us some feedback, so we can get better. So other than that, y'all have a great day. Enjoy the rest of your week, and we'll see y'all next month.
All right. Thank you.
Thanks, Zach.
Thank you. Y'all take care.